Hey guys, in my previous video I have explained an arithmetic progression and I have solved different arithmetic problems from the past year's national examination papers. In this video I will explain a geometric progression and I will show you the solutions of geometric progressions from the past year's national examination papers. So now I will take you to the definition of geometric progressions. Then we will proceed to the different national examination questions related with geometric progressions. So the formal definition of a geometric sequence is, as you can see here, geometric sequence is one in which the ratio between consecutive terms is non-zero constants, meaning that if we have a certain sequence, call it G1, G2, G3, usually we denote geometric sequence by letters G, G4, and so on. So this sequence is said to be a geometric sequence if the ratio between the consecutive terms G2 over G1 must be the same as G3 over G2, G4 over G3, and so on. Okay, all these things must be the same as some number, some non-zero constant R. This R is called common ratio. So a sequence is said to be a geometric sequence if the ratio between the consecutive terms is constant. So such constant is called common ratio. Now let's see a certain example on geometric sequence. Look at this numbers 3, 6, 12, 24. If we see this set of numbers 3, 6, 12, 24, and so on, we can guess what comes next after 24 by observing the sequence or the patterns of number. As you can see, every next term is 2 times the previous term. So in this example, we are asked the next 3 terms, okay? We are asked the next 3 terms that comes after 24. So look at this. The sequence is the ratio between the consecutive terms is the same. 6 over 3 is the same as 12 over 6, which is the same as 24 over 12. So you can assume this as G1. Say this is G2, 12 is G3, and 24 is G4. We are asked the next 3 terms that comes after 24. But when we see the patterns, the ratio of all these things is 2. This 2 is called common ratio. So the next term that comes after 24, say G5, should be 2 times G4. 6 is 2 times 3. 12 is 2 times 6. 24 is 2 times 12. Therefore, the 5th term is 2 times G4. The 5th term is 48. The 6th term is 2 times the 5th term, which is 96. The 7th term is 2 times its previous term, 96. The result is 192. So the next 3 terms that comes after 24 is 48, 96, 192. So it goes in this way. So the other question is, we are asked the 16th term. Come on, here the 16th term can be obtained by listing all the terms, but that is time taking. So we need a certain formula to calculate the 16th term. So the formula for the nth term is, the nth term of a geometric sequence is r to the power of n minus 1 times the first term. This is the formula. Therefore, the 16th term is r to the power of 16 minus 1 times the first term. But r is a common ratio, which is 2. Our common ratio is 2. 2 to the power of 16 minus 1 is 15 times the first term is 3. Or you can write 3 times 2 to the power of 15. This is big number. You don't need to calculate the detail of this thing, but simply you can put the 16th term is 3 times 2 to the power of 15. This is the 16th term. So here, this theorem tells us about the formula for the nth term that I have shown you before. The nth term, if it is not visible, the nth term for an arithmetic, for geometric sequence is given by Gn is equals to r to the power of n minus 1 times the first term. Okay, based on this formula, we will see some problems here. If we see this example, find the seventh term of a geometric sequence whose first term is 6 and whose fourth term is 1 over 36. So let us write the given information briefly. The first term denoted by G1 is already 6, and the fourth term denoted by G4 is 1 over 36. But from this formula, we know that the fourth term is given by r to the power of 4 minus 1 times the first term. Okay, the first term is 6. Now the fourth term is 1 over 36 is equals to r to the power of 3, 4 minus 1 is 3, times 6. So this implies r cubed becomes 1 over 36 times 6, which is 1 over 216. 1 over 216 means r cubed is equals to 1 over 6 cube, because 1 over 216 is 1 over 6 the whole cube. So the common ratio for this geometric sequence is 1 over 6. We have the common ratio, we have the first term G1. Now we can calculate anything. Here we are asked the seventh term. Now we can calculate the seventh term. The seventh term is equals to G1 times r to the power of 7 minus 1. Use this formula, the nth term for a geometric sequence. So the seventh term is equals to G1, meaning that the first term is 6, and r is 1 over 6. Okay, 7 minus 1 is 6. So this becomes 6 into 1 over 6 the power of 6. Or you can oversimplify this thing. This is 6 times 6 to the power of minus 6, which is going to be 6 to the power of minus 5. Or you can make it 1 over 6 to the power of 5. So this is the seventh term for the given sequence. Now, if you see this much, these two examples, now I will take you to the different national examination problems. But before going to the national examination problem, I want to show you this formula. This formula is about the sum of the geometric sequence. So the sum of a geometric sequence can be defined, as you can see here, in two different ways. N times G1, where R is 1. If the common ratio is 1, the sum of the first n terms of a geometric sequence will be n times G1. Otherwise, it becomes G1 times 1 minus r to the power of n over 1 minus r. Okay, this will be The second formula regarding the geometric progression is the sum of the first n terms of a geometric sequence. So we define, actually we use the same notation like that of arithmetic progression. Sn is the sum of the first n terms of a geometric sequence. It is defined in this way: n times g1, where the common ratio, whenever this holds, whenever the common ratio is 1. Otherwise, the sum of the first n terms will be defined as g1 into 1 minus r to the power of n over 1 minus r. This formula works for the common ratio is different from 1. So we will apply this formula to solve sum of geometric sequence. So here I have shown you two formulas regarding this geometric progression. Now I will show you the different problems of the past papers. Which one of the following represents a geometric sequence? So here we are asked to identify which of this sequence is geometric. So according to the definition that we have seen before, a sequence is said to be geometric sequence if the ratio between the consecutive terms is constant. Now let's check for A. If we see the A case, 3, 1, 1 over 3, 1 over 9, 1 over 27, and so on. And let's check the ratio. The second term over the first term means 1 over 3, and the third term over the first means 1 over 3 over 1, which is 1 over 3 itself. The fourth term over the first term is 1 over 9 over 1 over 3. This is also again 1 over 3. So definitely this is a geometric sequence because the ratio between the consecutive terms is constant. So by default the answer is A. You can verify that for B case. The second term, which is minus 1 over 3 over the first, is different from the third term, which is 1 over 4 over the second term. These two are different because this means minus 2, this means minus 2 over 3, and this one is minus 3 over 4. They are different, therefore this cannot be a geometric sequence. You can also verify that the sequence in C is not geometric because the second term over the first is different from the third term over the second. So this is the first term, this is second, third, fourth, fifth, and so on. So you don't need to check any other thing. The second over the first is 3, but the third over the second is 2. So this from this sequence we don't have common ratio. So this can't be a geometric sequence. Similarly for D case, the second term over the first is different from the third term over the second. The third term over the second. You can see that it is the first one is this one is minus 2, which is different from minus 3 over 2. By 3 it is minus 3, by 3 it's 2. So there is no common ratio for this sequence. So definitely our answer will be A. The other problem from the past national examination paper is if the second and fifth terms of a geometric progressions are minus 1 over 2 and 1 over 60 respectively. Look, let us write the given information first. The second term is minus 1 over 2, and the fifth term is 1 over 16. So based on this, we are asked the sum of the first 8 terms. We are asked S8. S8 is a shorthand notation for the sum of the first 8 terms. So let us first, from the given information, we need to calculate the first term and the common ratio. Definitely the second term is the first term times the common ratio, and the fifth term is r the power of 4 times the first term. Now if we take the ratio of the fifth term over the first term, we will get the fifth term is 1 over 60, and the first term is minus 1 over 2, which is the same as the fifth term r the power of 4 times g1 over r times g1. Now this g1 can be cancelled out, and this number becomes minus 1 over 8 is equals to r the power of 3, because r the power of 4 by r is r cube. Minus 1 over 8 is equals to r cube, implies r becomes minus 1 over 2. So we have here the common ratio for this geometric progression. We know that the second term, which is minus 1 over 2, is the first term times the common ratio, which is minus 1 over 2. So from this we can get that the first term is 1. So from the given information, we have the first term and the common ratio. Now we will apply the sum of a geometric progression, which is g1 into 1 minus r the power of n over 1 minus r. Since r is minus 1 over 2, we will apply this formula. So the sum of the first 8 terms is equals to g1 is 1 into 1 minus r the power of 8 over 1 minus 1 over 2. This is the same as 1 minus 1 over 256 over 1 plus 1 over 2. This will be 255 over 256 times 2 over 3. Now by 2, 1 by 2, this is 128. So the result is 255 over 3 times 128. 3 times 128. Actually, we can simplify this by 3. 85 by 3, 1. So the result is 85 over 128. Therefore, the answer for this, or the sum of the first 8 terms of the given geometric progression, is 85 over 128.